Hello everyone, Mr. Hissner here, and today is part 2 of the parallelogram proofs. Now yesterday we used the converse of the alternating interior angles. We used the converse. So that said that if the angles were congruent, then the lines were parallel. Today, so that was the definition of a parallelogram, in that opposite sides are parallel. Today, what we're going to focus on is proving parts of a parallelogram are true. So we're given a parallelogram. We're told this thing is a parallelogram. And from that, we can conclude some information. So let us look what we have here. I just kind of want to highlight these 4 properties. Now, these are our real 4 properties of a parallelogram. If you don't have these written down, if you don't have these kind of tattooed somewhere in your brain, you want to get these down. Opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. I like to think of this as diagonals make a midpoint. And then the adjacent angles are supplementary. So that's these angles that are beside each other. Angle 1 and angle 2 over here. Right there. So that those kind of angles beside each other, those are the adjacent angles. And let's hop into some of these proofs and just see how they're different. Notice the 3 that we have today, we're given a parallelogram, given a parallelogram, and then we are going to look at this one here, number 6. So we are told that this thing, RSTU, is a parallelogram. And this is not the definition, this is just given. This is given. So wide open here. So what I'm going to actually have a discussion here. What do we want to prove? We want to prove that angle U is congruent to angle S. How are we probably going to do this? Well, in the past, we would think of this as maybe using CTC. So if that's true, then maybe in the past we'd have to say, okay, 2 triangles are congruent. And actually, if you are familiar with this, if you have any recollection of this trauma that we experienced earlier this marking period, then you are actually ahead of the game, because that's kind of where this is going to go. Okay, so let's look at what we have here. We have not just one shared side. It's a parallelogram, so we know that opposite sides are parallel. Now wait a second, if opposite sides are parallel, then aren't alternate interior angles congruent? Yas or nas? The answer is yas. And if we look at that from that information, don't we have angle, side, angle? Don't we have angle, side, angle? We do. And so yeah, just really backing up through this, let me just go through this again. This is a parallelogram. Well, first of all, we have a shared side, right? So this is going to be either reflexive or symmetric property. It's a parallelogram, so both sides are parallel. If things are parallel, then we know we have alternate interior angles. If we have these pairs of alternate interior angles, then as we're looking at this, we have 1, 2, 3, angle, side, angle. So that's just what I'm going to go through here and write down. So let's just go through it and do this proof. So it's a parallelogram. That means opposite sides are parallel. So we have RS is parallel to UT. These are segments. And we have RU is parallel to, I think this is actually going to be TS. Be kind, rewind. That's the definition of a parallelogram. And so from there we have, okay, is parallel, so we have congruencies. We have the orange one first. This is angle U. R T is congruent to the other orange one, which would be angle S T R, 2 oranges. And then we have, okay, I have to kind of put these into both the same slot. We have angle R T U, and that is parallel, congruent to angle RTU, angle SRT, angle SRT. Hey, that's actually like a performance model Dodge. Weird. Okay, so this is what alternate interior angles are. Alternate interior angles. Alternating interior angles mean that the angles are congruent on either side of that transversal and also in the interior of the figure. So here we have our alternate interior angles, and wait a second, I think I'm missing a piece, I think I'm missing something, and I'm missing my middle segment here. This one looks like it's going to be RTTR. So this is segment RT congruent to segment TR. And this is a reflexive. No, it's not. This is symmetric. This is symmetric. This, all right. Okay, that's okay. That's right. That's okay. Crap. I gotta go back and fix these answers now. This lady messed this up. Are these all wrong? Oh, they're all wrong. That's okay. NBD. Okay, so now we have triangle RS, RST. Let's do that one. Is congruent to angle triangle RUT by angle side angle. And then since the two triangles are the same, we know these angles here will be the same. And this is going to be CPCTC. So really all the ones that we see today are going to end in this similar fashion. We're going to be given a parallelogram. We're going to have to use the definition of parallelograms. And then we're going to have to find two triangles that are congruent, make the pizza pie, CPCTC. Thanks for watching, guys.